Hello there. In this week, we're going to be learning about minerals. Okay, so I'm going to give you a little bit of the agenda on how this week is going to run. First, we're going to focus on the definition of minerals. We're going to introduce ourselves to minerals, and then we're going to look at the properties of mineral. Those are the two things we're going to focus on this video. But later on in the week, we're going to go further to our ESS ROT page number 16 and 17, where we're going to use the mineral flow chart to identify various minerals. And then late in the week, towards the end of the week, we're going to be looking at rocks and minerals and how rocks and minerals, how they interconnect. And if you recall, at the beginning when we started studying rocks, I did inform you that rocks are made up of minerals. So there's a connection between minerals and rocks. And finally, we would wrap everything up on ESRT page number 13. All right, so let's jump right in. Minerals, what exactly are they? For anything to be considered a mineral, it must meet 5 criteria. The first criteria is that it must be naturally occurring. This means that it is not made by humans, right? So a mineral like gold or diamond or silver or calcite or sulfur are not made by humans. They are occurring in nature by themselves. They cannot be created by humans. So that's the first order of things. A mineral must be naturally occurring. Number two, it must be inorganic. Inorganic is the opposite of organic. Organic things are things that comes from organisms, living things, animals, plants. Inorganic, on the other hand, are things that do not come from living things. All right. Organic things can decay, they can decompose. Inorganic things cannot decay, cannot decompose because they don't even come from life in the first place. They don't have life in the first place. So that is what it means to be inorganic, not to come from life, which means our diamonds and our sulfur, they do not decay. They can stay for a very long time, for the longest of time. All right. Then the third criteria is that a mineral must be solid. Liquids are not considered minerals. Gases are not considered mineral as well. So a mineral must be solid. The fourth criterion is that a mineral must have a chemical composition. We're going to do a little bit more of that on the slide. And lastly, it must have an internal structure. The atoms that are inside of the mineral must have a definite structure of arrangement. And more about that as we proceed. So talking about chemical composition, let's take the mineral halite, for example. This mineral is composed of sodium and calcium, right? So sodium and calcium are elements. So elements come together to form minerals, and minerals come together to form rocks. All right. So rocks are made up of minerals, and minerals are made up of elements. So the mineral here, halite, contains sodium and chloride. The mineral quartzite contains silicon and oxygen. So it's silicon dioxide. Dioxide is a fancy way of saying oxygen. More about that when you get to chemistry. Pyrite contains iron and sulfur, and we can go on and on. So every mineral has a definite chemical composition. That's the idea here. And then we said mineral must have a definite internal structure. This means the way the atoms of the minerals are arranged internally. Now, this internal structure will determine the crystal shape of the mineral and the breakage of the mineral, how the mineral breaks. Minerals can break in two ways. Minerals can break by cleavage, or minerals can break by fracture. All right, so the way the mineral breaks is determined by how the internal structure is arranged. And then lastly, the internal structure arrangement also determines the hardness. So in a nutshell, the way the atoms are arranged within the mineral will determine how hard the mineral is, will determine the cleavage or the breakage of the mineral, and the shape of the crystals of the mineral. So here is a good example here. We can see that this mineral fluoride has this cubic, all right, pattern of arrangement of the atom. So we see when the mineral breaks, it tends to form cubes. And the same thing applies to emerald. The way it breaks, it has that hexagonal breakage or cleavage because of the way the atoms inside of it are arranged. All right, let's move forward. Another classic example here is two different minerals here. We have diamond and then we have graphite. So this is diamond and this is graphite. Technically, they are both the same. They are made up of the same element, which is carbon. But based on the arrangement of the carbon, diamond is hard. It's so hard. Diamond is the hardest mineral on Earth. While graphite, on the other hand, which is the one you commonly find in your pencil lead, is so soft that putting it on paper can literally cause it to break. So when you write with your pencil, is the graphite literally breaking on your paper. So two identical minerals here containing the same thing, carbon, but just by the structure of the arrangement, it can determine the hardness, it can determine the other properties such as the way the mineral would break, the cleavage or the fracture of the mineral, and lastly, the shape of the crystals. All right, here are common examples of some minerals: olivine, pyroxene, amphibole, biotite, autoclase, feldspar, calcium feldspar, potassium perchlorate feldspar, halite, gypsum, limonite, hematite, calcite, muscovite, and the rest. You're gonna get used to this name as we get deeper and deeper into this week's content. But I just wanted to mention a few names so you know how they are pronounced and you start getting used to some of these names. All right, now we're going to talk about the properties of mineral. Properties of mineral. What we discussed earlier are the criteria for anything to be considered a mineral. Now, a mineral would have different properties. For example, a mineral would have a color, a mineral would have a streak, a mineral will have a luster, the breakage, cleavage, or fracture. You're going to have hardness, you're going to have crystal shape, and density. Now, it's possible for two different minerals to have the same color. So color is not really like a useful way of identifying minerals because it's possible that two or three or four different minerals can have the same exact color. So color will not be something that we'll focus heavily on, but rather we'll focus more on the streak, the luster, the cleavage, and the hardness, because those are really unique properties of several minerals. So streak simply means the color of the powder of the mineral. When the mineral is turned into powder, the color it has, that is the streak. Luster is how the mineral shines, how the mineral reflects light. Cleavage or fracture is how the mineral breaks. If it breaks and it forms a pattern, it's cleavage. If it does not form any pattern, it's fracture. Then lastly, it's going to be the hardness, how hard the mineral is. So let's talk about the luster. Up here we have three examples. I call this one, I call this two, and three. 1, 2, 3 have a metallic luster, which means they reflect light the way a metal would reflect light. The ones at the bottom are non-metallic, so we'll call this 4, 5, and 6. They don't shine. They are dull. They don't shine like a metal would. So that is it about luster, really. Metallic luster and non-metallic luster. Next, we're going to look at the hardness, which means how hard the mineral is. On your ESROT page number 16, I took the screenshot from that page. This is the Mohs hardness scale. It arranges minerals based on their hardness. So diamond has a hardness of 10, which means it is the hardest mineral. And talc has a hardness of 1, which means it is the softest mineral. So pay attention to this page and this particular table. We're going to be using it a lot this week. So hardness simply means how hard the mineral is. Now, halfway between the scale of 1 to 10, you're going to have the scale of 5 or 5.5, and a common thing that scientists would use that for would be using a glass. A glass has a hardness of 5.5. So if you take a mineral and you scratch it against glass, it's going to tell you if that mineral is hard or soft. So if the mineral scratches the glass, it means that mineral is hard. So which means the hardness number will be 6 and above all the way to 10. If the mineral does not scratch the glass, it means that mineral is soft, which means the hardness of that mineral will be below 5. So all of this will be soft and all of this will be considered hard minerals. So again, hardness is you scratch it against the glass. If it scratches it, it has a hardness higher than 5. If it does not scratch it, it has a hardness less than 5. Next is the breakage. The breakage is how the mineral breaks. So if it breaks and it forms pattern, like the first diagram we have here, you see that this mineral breaks like the pages of a book. So this is a little page that peeled off of this mineral. So it forms a flat, smooth surface, and that is called cleavage because it always forms a smooth, flat surface. Same thing here. It forms a square one. It forms a regular shape that you can easily recognize. A rectangular shape, a square, a triangular shape, any shape, rhombus, kite. You can see all of those shapes there. So if it creates any shape that you can recognize or it forms a flat, smooth surface, is cleavage. Fracture, on the other hand, is irregular. Fracture here is irregular. This will drive it home. So over here again, fracture, these are the irregular shapes, right? Forms irregular shapes. While cleavage, on the other hand, it forms definite shapes that you can easily recognize from here to there, there, on and on like that. These are shapes that you can easily recognize. So that's what cleavage are. Again, it is the internal arrangement of the atoms that determines how the mineral would break, how hard the mineral would be, and the crystal shape of the mineral. All right, lastly is the streak of mineral. We said streak is the powdered form of the mineral. So we create the powder form of the mineral by rubbing the mineral against the porcelain plate or the streak plate, simply put. So we're going to call this the streak plate. All right, so you take the mineral and you rub it against it. Whatever that color is the streak of the mineral. So it's possible for a mineral to be black and the streak will be blue. So take note of that. Don't just assume that every yellow mineral will produce a yellow streak or that every blue mineral will produce a blue streak. It's different. So that's why streak is a good way to identify minerals. Again, streak is the color of the powdered mineral. All right, I think those are the things I want us to focus in this video. So with those, we're going to jump into a little bit of practice and then I'll let you guys jump into your exit ticket. Let's look at question number 1 here. Question number 1 says, which property of mineral most directly results from the internal arrangement of its atom? Now we said, based on the internal arrangement of the atoms, it will determine the hardness of the mineral, the crystal shape of the mineral, and the breakage of the mineral, how the mineral would break. So what stands out here is crystal shape. Easy breezy. Question number 2. The accompanying table indicates the presence of various minerals in different rock samples. So we have granite, rhyolite, pumice, conglomerate, slate, marble, limestone, basalt, gabbro. And then said rocks are made up of minerals. So this table is letting us know the various minerals that are inside each of these rocks that we just mentioned a while ago. So granite has quartz, has potassium feldspar, pegoclase feldspar, biotite, hornblende. And then rhyolite has la 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 la, and pumice has la 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 la. So we get the point. Many of these rocks contains 1 or 2 or 3 minerals because minerals come together to form rocks. So the question says, which statement is an accurate conclusion based on the information provided in the table? Most rocks are monomineralic. Monomineralic simply means one mineral. Mono meaning one, mineralic, one mineral. So are most rocks monomineralic? No. The only one we see that is monomineralic is slate and marble, each of them containing only calcite. All other rocks contain different, so they are polymineralic. So many rocks are polymineralic. If a rock has only one mineral, that rock is monomineralic. So can we make that conclusion that all rocks are monomineralic? No. So A is out. All rocks are polymineralic. No. Some rocks are monomineralic, has only one mineral. Many rocks have a number of minerals in common. We can conclude that from the table. That could be our answer, option C. Only igneous rock contain quartz. That is not true. Conglomerate is a sedimentary rock and it has quartz. So D is out. Our answer here is definitely C. Question number 3. Base your answer to the following question on Earth science reference tables, the diagram and the table below, and your knowledge of Earth and space science. You have mineral A. Mineral A has this lovely pattern here. And the question says the original shape of mineral A was altered when it was hit with a rock hammer. Which physical property caused the mineral to break as it did? So this mineral was broken down. So after being broken down, we see that it formed a regular shape here. So it formed a square there. You can see another square here. You can see another rectangle there. Again, this looks like cleavage. Absolutely. So what exactly is in the mineral that makes it to break the way it's breaking right now? Is it the hardness? No, the hardness doesn't make it to break in pattern. So it's not the hardness. Is it luster? Luster is the way a mineral shines. So luster has nothing to do with the way a mineral breaks or the pattern in which a mineral breaks. Cleavage, more like it. More like it. The streak is the color of the powder of the mineral, and this has nothing to do with streak. So yeah, definitely our answer would be C right there. Question number 4. Using the luster of a mineral could determine by the luster of a mineral could be determined by using electronic balance. No, luster is the way mineral shines. A is out. Using a graduated cylinder. No. Observing how light reflects from the surface of the mineral. More like it, because luster is all about how the mineral reflects light. D. Observing what happens when acid is placed on the mineral. That is the acidic test. Acidic test is to know what the mineral is made up of, not the way the mineral shines. So this is art as well. Our answer is C. Last question. The photograph below shows the mineral muscovite mica. Which property can be observed from this photograph? I see that in the photograph it's peeling off like the page of a book is peeling off. So you can see that it has different pages here. All right. And this one is actually peeling off in that manner. So if it peels off and it forms a flat surface, we say that is cleavage. So yeah, this definitely is cleavage to me. Yep. It's not hardness. If it was hardness test, we have a glass nearby or a glass plate nearby. It's not magnetism. If it was magnetism, we'll have little ions around to see whether the mineral can magnetize those ion filings. Streak, you need a streak plate to produce a streak out of a mineral. So yeah, our answer definitely is cleavage. All right, that's a wrap on today's class, and I'll see you guys in the next video. Bye for now.